Today we're going to be modeling this memorial in Hiroshima Peace Memorial Park using a quadratic equation. Okay, so we can look here. This looks like a parabola shape. But we're going to model the outside of the shape, which I have the dimensions for. According to my online sources, the height is 3.7 meters and the width is 4.4 meters. So we're going to model this in Desmos, and in Desmos you can click here, upload image, and here we go. Here's the Hiroshima Memorial, and let's wait for that to upload. So I'm going to move this over here. Make sure you move it and not stretch it because you don't want to mess up the proportions. Actually, we know the vertex, if we look back here, the vertex, if we start here at 0, 0, the origin, then the vertex will have a y value of 3.7, and we know the axis of symmetry is going to be x equals 2.2, because that's halfway from 0 to 4.4 is 2.2. So the vertex should be 2.2 comma 3.7. So we can actually make that point on Desmos. 2.2 comma 3.7. So the vertex should be right there. Alright, so we're going to make this a lot smaller by dragging here. Make sure the whole thing is shrinking in proportion. Okay, let's move it on over here. So that's touching at the origin. Make it a bit bigger. That looks like about the right height now. Okay. A bit smaller, and move it over a bit. Okay, that's about correct now, I think. Okay, so let's leave it like that and not zoom in anymore. Okay, so we have the parabola. Now we're going to try to make an equation for it. We have the vertex, and so let's start doing some calculations here. So in vertex form, we have y equals a times x minus the x value of the vertex squared plus the y value of the vertex. Okay, so we just got to figure out what that a value is. So to do that, we can just substitute in a point. So we have also the point 0, 0, and we have the point 4.4 comma 0. So I guess 0, 0 is the easy one to plug in or substitute in. I'm going to sub in 0, 0. So 0 equals a times 0 minus 2.2 squared plus 3.7. Alright, so 0 equals 2.2 squared times a plus 3.7. So a equals negative 3.7 divided by 2.2 squared. Okay, so I'm going to do that on my calculator. And we have negative 3.7 divided by 2.2 squared equals negative 0.764. Negative 0.764. So our model is y equals negative 0.764 times x minus 2.2 squared plus 3.7. Okay. So next we're going to write this in this is vertex form. We're going to write this in standard form, and then we're going to write this in factored form. Okay, so standard form is easy. We just expand this and multiply by this, and we simplify. Okay, so we're going to have negative 0.764 times, this is going to be x minus 2.2x minus 2.2x, so it's going to be 4.4 x, and plus 2.2 squared, which is 2.2 squared. Let's work that out. 2.2 squared, enter, is 4.84. So 4.84 plus 3.7. And then that's, oops, that should be squared. Then we'll expand this. We'll have negative 0.764x squared plus, now let's do 4.4, and instead of multiplying by 0.764, let's multiply by the exact number up here. Okay, and that should be positive because I'm doing negative times negative, so that's 3.36. 3.36x. And then next we're going to multiply 4.84 times negative 0.764. Actually, oops. Let's go get the exact value up here. Okay, and it's negative, oh really, exactly negative 3 point, that's surprising. This times this gives you exactly negative 3.7. Oh, that kind of makes sense because the y-intercept of the parabola should be 0, right? Okay, we know from these cancel out and you get 0 as the value right here, and we know that kind of makes sense because in the picture 0, 0, 0 is the y-intercept, so this should be 0 over here, right? So this is standard form. Now for factored form, it's always the same a value, so it's going to be negative 0.764 and times x minus, then we get the x-intercept, so one x-intercept is 0, the other x-intercept is 4.4, so this is the answer in factored form. Okay. Now, so let me write that down. This y equals, I'll write down standard form. Negative 0.764x squared plus 3.36x. So I will show that now over here. Y equals negative 0.764x squared plus 3.36x. So you can see it's not a perfect fit. It does go right through the vertex, and it goes through these x-intercepts because that's the way we designed it. But it's actually not quite exactly a parabola shape. It's actually a slightly different shape called a quaternary. All right. So if you want to make a bit of a better model, maybe you can try maybe making it a bit wider. What happens if I do 0.8? Oh, that makes it smaller. You can kind of play around with it a bit. Maybe you want to play around with it with vertex form. Let's write it in vertex form. So vertex form, we had 2.2 and 3.7, so it should be negative 0.764 times x minus 2.2 squared minus 3.7 plus 3.7. Okay, so that gives us the same thing as we just had, but if we want to make it wider, we can. Or let me try that at 6. So that's a bit too wide. We can increase the x-intercept to like 3, or the vertex a bit. Actually, this is not getting better, is it? Alright, so maybe you can try a little bit of a model like that, or like this would be a bit better. But it's not quite a perfect parabola shape, right? One thing you could do is you can look at the distances here and add those some of these distances up to figure out the mean error between the parabola shape and the actual shape.